the day. Today I am going to explain parallel computing lab programs. This is Dr. Pavitra A.C. working as an associate professor in the Department of Computer Science and Design, ATME College of Engineering, Mysuru. Now I'll be explaining the fourth program. The program says write an OpenMP program to find the prime numbers from 1 to n employing parallel for directives. Record both serial and parallel execution times. This program is executed in the Ubuntu 11.4.0 with the version 22.04. And what is prime number? This prime number is a positive integer that is divisible by only 1 and itself. For examples, we can say 2, it is divisible by 2 only, and 3, it is divisible by 3 and 1, and 5, 7, 11, so it goes on. Now let us see the code for this prime number. The code says hash include stdio.h. These are the standard input output functions, and we are including omp.h, which says OpenMP library for parallel programming. So we are including both standard MP and standard input output and OpenMP library for parallel programming. Now let us initialize the program with void main integer 1000000 ijn. This is an array to mark prime numbers, where 1 says it is prime, 0 is it is not prime. And integer ijn, we are considering it for loops, and the upper limit we are considering here as n. Now prompt the user to enter the inputs. So now we are going to enter the input in the next line, that is with the /n. In order to find prime numbers from 1 to n, enter the value of n, because n is the largest number we are using here. Now use scanf, then initialize all the numbers as prime. Here we have to set all the values to 1. So now initialize the values for I is equal to 1 with I less than 1 and I plus plus. Prime of I will be equal to 1. If 1 is not a prime number, mark it as non-prime. So that means it will be 0. Now, so if it is not 1, it will be marked 0. Now, see of this electrostatic algorithm, this loop runs till I into I is equal to or less than n, because multiple values are below I into n, that is already marked. For I is equal to 0, I into I with less than or equal to 1 with I plus plus, parallelize the inner loop using the OpenMP. This loop marks multiples of I. So here this loop marks multiples of I as non-prime. Now pragma OpenMP parallel for. So you have to initialize this pragma for OpenMP. For I is equal for j is equal to I into I, j is less than or equal to n, and j plus I. So if prime of j is equal to 1, then initialize the next value, otherwise mark it as non-prime. Now you have to print all the prime numbers. So print the prime numbers from 1 to n. So whichever the number n is given by the user. For I is equal to 2 and with less than n and I plus plus, it prints the exact value of prime if it is equal to 1, otherwise it prints as non-prime. Now printf the I and the maximum number. The output will be, so here we have to compile the program. So the program named here it as prime.c. So for compiling in OpenMP, we are going to use gcc -f OpenMP prime.c. So this is the compiler one. And the next one, a dot slash a dot out. This is the default name. So this is the default name for the output of a GCC style compiler. So now we are going to enter the values from 1 to n. So here it is entered as 100. The prime numbers from 1 to 100 are printed as 2, 3, 5, 7, 13, 17, 19 up to 97. So this is the output of the prime number. Thank you for watching the video.